Hello, welcome to our class. And today I want us to be able to have a discussion on the Karl-Pearson correlation coefficient, or sometimes what we call the product moment. The product moment correlation coefficient. So we are going to have a discussion on that, the Karl-Pearson correlation coefficient, and the other name of the Karl-Pearson correlation coefficient is actually the product moment correlation coefficient. So the Karl-Pearson correlation coefficient, or the product moment correlation coefficient, is going to explain the degree of relationship between two variables. Trying to explain that kind of particular degree of relationship between two variables. So we are going to be given two variables that we should be able to use in terms of calculating the Karl-Pearson correlation coefficient, or the product moment correlation coefficient. So in the exam situation, sometimes they can give you that question and they call it the Karl-Pearson correlation coefficient. And again, in some exams, they will just ask you to calculate the product moment correlation coefficient, so it means the same. So the Karl-Pearson correlation coefficient, I'm just going to start by actually giving you the formula, and remember you have said that the key thing is going to explain the degree of relationship between the two variables. So which is the formula that we should be able to use in terms of calculating that Karl-Pearson. So I'm going to give you the formula, and then I'll give you a simple example, and then we'll be done with this kind of particular Karl-Pearson. So Karl-Pearson, first of all, is going to be represented by small r. So Karl-Pearson will be represented by that small r. So later on, we'll be able to discuss about the Spearman's rank correlation. When we talk about the Spearman's rank correlation, which we are going to discuss in the next video, is going to be represented by capital R. So rank correlation, the Spearman's rank, is always R, the capital R. But when we talk about the Karl-Pearson, or the product moment correlation coefficient, it is actually going to be represented by this small r. And the formula for this kind of particular particular topic is that the Karl-Pearson is going to be as follows. So the formula will be as follows. So we take n summation xy. So it's more of the regression. Remember when you were calculating the regression, the getting b, which was the slope, that's what we usually start with. But something is going to change a little bit, and I'm going to show you that. So it's going to be n summation xy minus summation x summation y, and where this dot here is going to signify multiplication, and also we have another dot here that will actually signify again that multiplication. So n summation xy minus summation x summation y multiplied by summation y over so again, I'm just doing like getting b. Remember when we calculated the regression, and I have the video of regression, you can be able to check in that channel. So this is more of getting b, but we are going to change some elements here. We are going to add, not even changing. So divided by n summation x squared minus into bracket this one. So this one, now people make mistake. So start by putting that bracket, and you put that square outside that bracket, and the element that is going to be inside here is summation x. So don't do a mistake of putting x, this square inside this x here. You will just be able to get a long answer. So you put the bracket first, and then the square, this square should be outside that kind of particular bracket. So you see, this is the formula of getting regression. Under regression, when we are calculating the regression equation in the form of y is equals to a plus bx. This was the formula. But now, what we are talking about here, we are talking about the product moment correlation coefficient. And the product moment correlation coefficient, we are going to add some extra elements here. So under the numerator only. So the denominator will remain intact just like the way it is under regression. And I've told you that you check the regression video so that you can actually relate this kind of particular two things here. So under the numerator, then we are going to have a multiplication in that numerator. Then we are going to repeat everything. We are going to repeat everything the way it is under the numerator here. But now where we have x, we are going to replace it with y. So where we have x, we replace it y under the numerator. In the sense that this is how it is going to happen. So you start with n as usual, the way this n is here. Summation. Now instead of having summation x, now it's going to be summation y squared. And then minus, the way minus is here. Again, I told you that you put a bracket in that way, and you put the square. That square should be outside this particular bracket. And in this case, again, now it's going to be summation x. It's not going to be summation x, but summation y. So you put summation y. So it's going to be summation y, you close the bracket, and then you square it. And everything that is under the numerator, it should be under square root. So what we are going to do, we are going to have a square root all the way to the last elements there. And that's the regression. I mean, that is the Pearson formula, or what we call the product moment correlation coefficient. So that's it, and that's how you can actually be able to remember it easily. It is actually related with the regression. So even in terms of calculating the tables, when we are going to be given the tables, we are going to see it's more of the same, but we are going to add the y squared only. In the sense that, this is what actually I'm saying, you can be given a question like this. You are going to be given the two variables, and the two variables are going to be x and y. So we have those two variables, x and y, and the variables may be we have maybe 2, 3, 6. 2, 3, 6. So let us have 3 of them so that you can develop an understanding easily. And then on y, you can have maybe 4, 3, 8. So we have those kind of particular variables there. So the sample size, which is n, because n will always represent that sample size. N in this case is going to be 3. It's just this 1, 2, 3. It's going to be 3. So sometimes, of course, in the exam situation, they may give you several. They can give you up to 7. They will list up to 7, and then n maybe will be 7. Sometimes it can be 6. So depending on the type of the question that the NEC wants you to be able to answer. So you have x, and then you have y there. And then they ask you to calculate the Pearson. You calculate the Pearson correlation coefficient. And the Pearson correlation coefficient, we have said that we are going to apply to this kind of particular formula, and it's going to be represented by that small r. So how do we go about it? You have two variables, x and y. It is actually simple. It is very simple. Even there are some few marks that you need to get without actually much thinking, because you check this summation x, because the formula is the guiding principle. That's why the formula, you must be able to know it very well. So in the numerator here, you can be able to see we have summation x and also summation y. So under the numerator, we start with those things that are in the numerator. You can be able to see we have summation x and also the summation y there. So what you do, because it is that summation x, so summation x is basically coming here and adding every elements that are going to be under this particular x and the column of x, so which is going to be 6 plus 3, which will be actually 9, and then plus 2, which will be actually 11. And then this one, if you just add it, it is going to be 15. So 8 plus 3 plus 4, then it's going to be 15 there. So that's how you start earning those kind of particular marks. Because now we have our summation x, we also have our summation y, which we have actually done here by adding the values of x. We have also added the values of y. The next thing that we do, from the equation here you see, again in this numerator, you can be able to see we have summation xy. So meaning that we are going to add another kind of particular column, which is going to be xy. So xy. So maybe to light every column that we are going to have here, we are going to have xy, and then we are going to have this x squared. So you can be able to see we have added two columns, which is the column of xy, of which we are going to get also the summation. We have added the column of x squared, of which again we are going to get our summation. So if you can be able to remember, under regression, this is where we stopped in terms of those kind of particular making more columns. We usually stop at x squared under regression analysis. But now in a correlation, which is the Pearson, there's one more column that we are going to add, which is actually the column of y squared. So what we will be able to add here is y squared. And y squared, it is going to emanate. It is going to emanate from here. This is where y squared is coming from. So under the Pearson, whenever you see that you have to calculate Pearson, because x and y they are going to give you. So what you are going to add is xy, x squared, and y squared. That's what you are required of you to be able to have there. So xy, because this is actually was 4. So xy, what it simply means is that we are going to calculate the 2 times 4, so that we get that xy, 2 times 4, which is going to be 8, and then 3 times 3, which is going to be 9, and then 6 times 8, which is basically going to be 48. So you see, now we have xy. And of course, we can now be able to get the summation of xy, because they are saying that we get that summation xy there, so that we can be able to follow the formula, because here you see it is summation xy. So we have to get that summation xy, and it is going to be that 48 plus 9 plus 8, which is actually going to be 65. So you see again, we have our summation xy as the formula dictates, which is 65. Now let us get x squared. So how can we be able to have x squared? X squared is simply squaring the values of x here. So it's going to be 2 squared. We square this 2 squared here, which is going to be 4. 3 squared, which is going to be 9. And then 6 squared, which is going to be 36. Again, if you can be able to see x squared here, they want you to get summation x squared, the way the formula is dictating us to do. So you see we have summation x squared, and what we do again is to have the summation. So we are going to take this 36, we add this 9, we add also this 4, so which is going to be 36 plus 9, and then plus 4, which is going to be 49. It's going to be 49 there. And then you should actually be able to get y squared. And y squared is actually squaring the values of y here. So it is going to be this 4 squared, which is actually going to be 16. And then you are going to have this 3 squared, which is going to be 9 stating here, we need to get the summation y. Summation y squared. That summation y squared there, it simply means that we are going to come to this column of y squared, we sum them up. So which is going to be 64, we add 9, we add 16, and then we get 89. So by you doing this in your next exam again, you will have some marks there. And that's what you do. So that's the basic things that you need to be able to understand. And the key thing is understanding that formula. Now the moment you have all this information, you just take it to the formula there, and then you get your R. And how do we get our R? So let us apply that kind of formula. So our R is going to be N. N is always the sample size, the size of the sample. And the size of the sample here, you can be able to say our sample size is 3. The sample size is 3 in the sense that, and this is what I'm saying. So this sample size, you see it was 2, 4, and then 3, 3, 6, 8. So meaning that the sample size is just 3, you just count them 1, 2, 3. If maybe we were to have more, maybe 5, 9, maybe 10, 15, then the sample size changes because the sample size in this case is now going to be 1, 2, 3, 4, 5. So the sample size, remember I said it can be 7, it can be 6, it can be 8, it can even be 10, it can also be more than 10, sometimes up to 12. So depending on that question. So in this case, the sample size is 3, and I'm using 3 to develop your understanding on that one. Because I want you to have a very good understanding of this Karl Pearson correlation coefficient or the product moment correlation coefficient. So now, we have seen where 3 comes from, so it's going to be N, which is actually 3. And I told you that where I have a dot, even here we need to have some dots, meaning that we're going to have a multiplication there. So even here, we will be able to have it. So it's going to be 3, which was N, the sample size, multiplied by, so where that's the dot is there, we're going to multiply by summation xy. And summation xy is what we have actually calculated here. So you see xy, the summation of it is 65. So multiplied by 65. And then, so let me put it inside a bracket for neatness so that you can follow it in a proper way. So minus summation x. You can be able to see that summation x in this case is 11. So summation x will be 11. So it's going to be that 11 multiplied by, because there's a dot here signifying that it will be multiplication. So multiplied by summation y. And summation y is actually 15. It's going to be 15. So also let me put that one inside a bracket there for neatness, the neatness purposes there. And then over, so you see everything is over here, n, and maybe before we go to n, there is a likelihood that you may end up forgetting this root. So it's better we have this square root to the far end there under the denominator, because you see there the denominator has that kind of particular square root. So what we do then is going to be this n under the square root here. It's going to be n, which is 3 dot, which means multiplication there. So multiplied by summation x squared. And summation x squared in this case, summation x squared is actually the one that you see here. So this is x squared, and the summation x squared, you can be able to see, it is actually 49. So multiplied by 49. So I can also put this one inside a bracket in that manner. And then minus. So this is where now you must be extra vigilant in terms of computing it, because that's why we are likely to make a mistake. So it is saying summation x into bracket squared. Most of the people confuse, and they are going to take this 49, which will be wrong, because they are saying summation x, and then we squared. So the thing that you need to be able to do there, so that not to confuse, just put that bracket the way it is, and then put the square outside. And what should be inside that particular bracket is summation x. And summation x in this case is actually 11. So you put that 11 there. So by you doing that, I do believe that you cannot easily confuse. So you put the bracket, and then the square should be outside this kind of particular bracket. And then we multiply by, again, we are going to have our n, and the n in this case is 3. So it's going to be that 3 multiplied by, so this dot again signifies multiplication, so it's n multiplied by summation y squared. So multiplied by, so let me put a bracket here. So it's going to be 3 times summation y squared. And summation y squared is the sum of the y values, the y squared values, which is 89. So which is that 89. So multiplied by 89, that manner. And then you close this kind of particular bracket to make it neat. And then you minus summation y squared. Again, this is just like what we have done here. So when you see that kind of particular thing, what you need to do, just first of all, put that bracket, and put the square outside the bracket, and what is inside that kind of particular square root, not the square root, but inside that bracket, is actually summation y. And summation y in this case is 15. So that's how you can easily be able to get it right, so that you don't end up writing 89 again. So what is inside the bracket is summation y, and summation y is 15. So you pick this 15, you put it here. So that's what you need to be able to do up to there. And then let us start with this numerator part. So we are going to start with 3 times 65, this 65 here. So which is going to be 3 multiplied by 65. And the 3 multiplied by 65 is going to give you 195. And then you minus. So it's going to be 195 there. So let me just adjust the camera so that you can see everything there. So it's going to be 195, you minus 11 times 15, which is going to be 165. 165. So this is, it was all about the numerator. Let us now go to the denominator here. So which is going to be over, so you have our over there, and the over in this case, they are saying 3 times 49, so it's going to be 3 multiplied by 49, and 3 multiplied by 49, we are going to have 147 minus 11 squared, which will give you 121. So this 11 squared is 121. So let me put that bracket again. So I done from here up to there, and then of course there is this multiplication. So multiplied by 3 times 89, again 3 times 89 there, which is going to be 267. So it will be 267 minus 15 squared, which is 225. which is 225. Then we close that kind of particular bracket in that kind of particular manner. So what we are going to do there, so let me again adjust the camera so that you see what I'm going to do to the far end. So it's going to be 195 minus 165. So we take 195, we minus this 165 there. Then we are going to have that, so it's going to be 30. So it will be 30. And remember, before I forget, that everything in the denominator is always under square root. So it's going to be 30 over. So let us always have that square root so that we don't end up forgetting. So remember that everything in the denominator should be under that square root. So it's going to be that 30 over the square root itself. So it's going to be 147 minus 121. 147 minus 121, which is 26. Times 267 minus 225, which is 42. Which is 42 there. So maybe let me continue it in this part here. Just demarcate those lines. So I'll continue it here and I finish it. So it is our 30. So our R is going to be 30 over the root of, or the square root of 26 times 42. So 26 times 42 is going to give you 1092. So 1092 there. So that's what you are going to have there. And then your R is going to be 30 over, so the root of that 1092 is going to be, so the root of 1092, the square root of that one, you are going to have 33. Let me put it up to 4 decimal places. So it's better to put it up to 4 decimal places. It's going to be 3.04 and then 5 4 0454. So that's up to 4 decimal places there. It's always advisable. So our R then is going to be 30. We divide it by this 33.0454. And then your R, which is that Carl Pearson, is now going to be 0.9078. And that is it. And that's how we get the Carl Pearson correlation coefficient, or the product moment correlation coefficient. So that's how you get it in that simple way. And it is the answer that you get under the Carl Pearson should always be less than 1. So if you calculate Carl Pearson and then you get 1.5 or 22 or 1 million, then you will be wrong. So the answer should be 0 point something always. Sometimes it can be negative 0.7, I mean negative 0 point something. It can also be a positive, but it cannot be more than 1. So that's what you need to know, and that's the indicator that we got it right. So if you get more than 1, maybe you get R is equals to 50, R is equals to maybe 10, then it will actually be wrong. So it's going to be always be 0 point something. So that's the product moment correlation coefficient, or the Carl Pearson correlation coefficient. So thank you, and in the next video, I now be able to discuss about the rank, the Spearman's rank correlation, which now is going to be represented by a capital So thank you.